All right, everyone, welcome to our deep dive today.
Yeah.
I know you guys are all swamped with the AI and radiomics material,
Yeah.
so I thought it would be good to kind of like unpack some of the ideas from Lecture 9,
Sure.
especially all that stuff about using AI to look at those 3D models of the adrenal glands.
Yeah. Yeah. No, it's a fascinating area, We're really using the power of computers to, potentially
Right.
make diagnoses faster and more accurate. Imagine being able to just tell if a gland is normal or has hyperplasia just from a scan.
Right.
That's what we're kind of diving into today.
Yeah, and the lecture notes walk us through this whole 6-step radiomics workflow. Seems really complicated when you first look at it, but it's actually pretty logical.
I think if you think of it as a step-by-step process, like a recipe,
Okay.
with AI as the key ingredient.
I like that. Okay, so first
Yeah.
off, we need the images themselves, right?
Right.
And we got to zero in on, what area we're interested in. So it's like choosing your ingredients.
Exactly.
Yeah.
Then comes feature extraction. And this is where it gets interesting because we're not just looking at the image, we're extracting data from it.
Oh, so it's not just like there's a gland. It's like the gland have this volume and this surface area and this texture.
Precisely. We're turning visual information into data points that the AI can understand and work with.
Okay.
Yeah.
And then we go to pre-processing. So we essentially clean up that data and pick out the features that seem like they're going to be the most helpful.
Right.
Kind of like a chef, who knows which flavors are going to make the dish really sing. You know what I mean?
It's all about focusing the AI's attention on what's most likely to be relevant for the diagnosis.
Right, because not all data is created equal.
Exactly.
And then we get to like the heart of it, right? AI model development.
Yes.
This is where the AI is actually learning how to connect all those features to a specific diagnosis.
It's learning to see patterns in the data that correlate to different conditions, just like a radiologist would.
But just like with any student,
Yeah.
we need to make sure that it's actually learning. So there's the
Yes.
training,
Yeah.
validation, and testing.
Exactly. We want to make sure it can apply what it's learned to new cases and make accurate predictions.
And then last but definitely not least, explainability,
Yes.
especially in medicine. We can't just have a black box spitting out answers.
Oh, of course not.
We have to know why the AI came to the conclusion that it did.
It's about building trust. If we can understand the reasoning, we're more likely to accept it.
Right. That makes total sense.
Yeah.
So we've got the workflow down.
Mm-hmm.
Let's actually talk about that data set that you had us looking at. Adrenal MTISTD.
Right.
What's the deal with that?
Well, this data set is a collection of 1584 3D models of adrenal glands,
Okay.
each carefully labeled as either normal or showing signs of hyperplasia.
I was reading that those models came from Zhongshan Hospital.
Yes.
That's pretty cool. We're working with real-world data.
Yeah.
Even if it's not the actual patient scans.
Absolutely. And it's just the models, so that helps protect privacy.
Right. So the AI's job is to figure out how to tell the difference between these normal and hyperplastic glands just based on those 3D models.
It's like training the AI to be a detective,
Okay.
looking for those subtle clues.
I see. And the lecture notes mentioned two main approaches. One was kind of analyze everything, like don't leave any stone unturned.
That's one way to go, extract all possible features from those models.
So like everything from how big it is to the texture and everything.
Yeah, everything from volume and surface area to more complex things like the texture and the spatial relationships.
So even just how big the gland is could be a clue.
Absolutely, size can be a factor, and even subtle variations in the shape can be valuable too.
And then there was the second approach, which seemed more focused.
Right. Instead of just throwing everything at the AI,
Right.
we can be more selective and focus on features that we think might be particularly relevant.
Interesting. So it's kind of like you're choosing to analyze just the ingredients that really matter for the taste of the dish,
Exactly.
So which approach works better?
Well, that's where things get interesting, and that's what we're going to delve into next. Yeah. So it turns out that both approaches, they have their pluses and minuses.
Right.
And the best approach often depends on, the data set, the type of diagnosis you're trying to make.
Okay.
The lecture notes really go into detail about the different AI models and how they performed with these different feature sets.
I'm going to admit, I got a little bit lost in all the numbers.
Sure.
But one thing I did notice is it seemed like those shape features
Yes.
were really good at predicting hyperplasia.
That's a great observation.
Yeah.
You're absolutely right. It turns out that the shape of the gland can be a really strong indicator
Okay.
of whether or not it's normal or hyperplastic.
So even if we don't analyze every little detail,
Right.
the AI can still pick up on these shape clues.
Exactly. And sometimes simplifying things by focusing on a smaller set of relevant features
Right.
can actually lead to more accurate results.
So it's not always about more data.
Right.
It's about the right data.
Exactly.
And it sounds like feature selection is important for that.
Absolutely. Feature selection is kind of like giving the AI a roadmap.
Okay.
It highlights the most important landmarks to pay attention to.
I see.
The lecture covers a few different techniques for doing this,
Mhm.
and some really interesting results came out of those experiments.
I remember seeing those results in the notes, and one thing that really stood out to me was that
Yeah.
sometimes even when you used all the features,
Yeah.
the performance wasn't always better.
That's a really important point. More data doesn't always equal better results.
Right.
In fact, sometimes having too much information can actually make it harder for the AI to learn.
So it's like you're giving it too many ingredients.
Exactly.
And it ends up kind of muddled.
Right. Feature selection helps us refine the recipe and create a more focused learning experience for the AI.
Makes sense. So not all data is created equal.
Exactly.
And finding the right data is key.
Right. And remember, all of this is ultimately about using AI to improve patient care. You know, if we can train these models to tell the difference between normal and hyperplastic glands, it could have a huge impact on diagnosis and treatment.
Yeah, I can definitely see how this could be a game changer.
Absolutely. Early diagnosis can make a huge difference for patients.
For sure. And this AI stuff, it's not limited to just adrenal glands, right?
Not at all. It has the potential to be applied to all sorts of medical images.
Wow.
From x-rays to mammograms to even pathology slides.
So what we're learning here
Mm-hmm.
has implications way beyond just this one application.
Absolutely. The principles of radiomics and AI image analysis are incredibly versatile.
It's pretty incredible.
And as future medical professionals, you guys are going to be on the front lines of using these tools.
Wow. No pressure.
Right.
It's amazing to think about how the things we're learning here
Yeah.
could actually help people down the road.
That's what it's all about, using our knowledge and skills to make a real difference.
This has been a great overview.
Good.
I'm sure the rest of the class will find it really helpful.
Yeah, I hope so. It's always fun to delve into these topics with engaged students.
So we've covered the workflow, the data set,
Mm-hmm.
the different approaches to feature extraction,
Mm-hmm.
and how important feature selection is. Is
Yeah.
there anything else we should touch on before we wrap up? You know, one thing that struck me when we were talking about all those different approaches to feature extraction is that it seems like it's almost like an art as much as a science. You know what I mean?
Yeah, there's definitely a balance between, being comprehensive and being selective.
Right.
Sometimes you need to analyze everything, and other times it's better to be more focused in your approach.
And it seems like that's where experience and domain knowledge come in.
Exactly.
Knowing which features are going to be the most important for a certain diagnosis.
It's like an experienced radiologist develops an eye for those subtle abnormalities.
Right.
And in the same way, we can use our knowledge to help guide the AI.
So it's not just letting the AI figure everything out on its own.
Right.
We're still the ones kind of steering the ship.
Right. Yeah.
Exactly. We're the mentors.
And speaking of predictions, this whole deep dive is making me think about, like, the future of diagnosis.
Mm-hmm.
It seems like AI could totally change how we detect and treat diseases.
It really is an exciting time to be in this field.
Yeah.
We're already seeing AI being used to improve cancer detection, diagnose neurological disorders, personalized treatment plans.
It's crazy to think about all the possibility.
Yeah.
And the fact that we're learning about this stuff now in class feels pretty cool.
You guys are at the forefront of this technological revolution.
Yeah.
You have the opportunity to shape how AI is used to improve healthcare.
No pressure, right?
Yeah.
But seriously, it is really inspiring
Yeah,
to think about how this could actually help people.
that's what it's all about, right?
Yeah.
Using our knowledge to make a difference.
As we wrap up this deep dive, is there one big takeaway that you want us to remember?
I think the most important thing is to be both enthusiastic and critical.
Okay.
Be excited about the potential, but don't forget about the limitations. Ask questions, challenge assumptions, and always make sure you're using AI ethically and responsibly.
That's great advice. So to all my students in the AI and radiomics class,
Mhm.
keep learning, keep questioning, and keep pushing the boundaries. The future of medicine is in your hands.
And remember, this deep dive was just a starting point.
Right.
There's still so much to learn and discover, so go out there and explore.
That's a wrap for today. I hope this helped clear up some of those concepts from Lecture 9, and that it made you curious about AI in medicine. I'll see you all in class.